Hi everyone. In this section, we are going to talk about data structures, quick recap, and C++ STL. So C++ STL stands for the standard template library. It is a library that provides us common algorithms like searching and sorting. So there are functions that are there in the algorithm header file. It provides us with data structures like the containers for stack, queue, array, vector, unordered map, so on. And all the containers are built using templated classes. Okay, so that means you can fit any data type into that container. Okay, so that's more like a generic container. Okay, you can create an object for any particular data type as well. So this framework is similar to the collections framework in Java. If you're coming from Java background, you might have heard about the collections framework. The similar kind of a thing in C++ is known as standard template library, or STL in short. So we are going to give you a quick recap of what is a container. So a container is an object that stores a collection of other objects. Okay, so these objects are also elements. So these objects could be as simple as integers. Okay, let's say an array of integers. So we can say the integers are stored inside a array container. Or maybe I might have a class cat. I might have some cat objects, and I'm storing lots of cat objects inside a container. Okay, so I can say an array of cats. That is also fine. Okay, so the object can be as simple as an integer, or it could be something complex like a cat, which may have certain attributes like color, height, size, okay, weight, maybe some methods as well. Okay, so container can store objects as well. Okay. So container manages the storage space for its elements and provides member functions to access them. So mostly through iterators. So iterators is again a very important concept. So now if you have this array, you can simply iterate it using a variable. Let's say starting I is at 0, I is at 1. But suppose if your container is complex, okay, maybe your container is implemented using a tree-like data structure. Okay, in that case you cannot say I can iterate simply using an index. So what you will need is you will need an iterator, okay, to iterate over the different nodes of this particular tree. Okay, or if you have a hash map, if you have a container which is implemented using a linked list, then also you will need a iterator to iterate over the different nodes in that particular linked list. Okay, so iterators will allow you to iterate over the different nodes that are there inside the container. Okay, so there are also objects which behave like pointers. Okay, so they know how to move forward. Okay, and they are defined for each of the containers that we have. Okay, so an example of a container is a stack or a map or a vector and so on. So the containers in STL are divided into four broad categories. The first set of category is known as the sequence containers, okay, in which the data is stored linearly in a sequence. Like array is a sequence container. Okay, you store all the elements linearly inside an array. Okay, a vector is like a dynamic array that can grow in size, but again the data is stored linearly inside vector as well. Okay, so array has fixed size, but the vector can grow. Okay, there is something which is known as Deque, which is known as doubly-ended queue. It is also a linear container, and the thing with this container is it can expand both from the front and both from the back, and it can also contract both from the front and both from the back. So it is known as doubly-ended queue. So you can see you can do the operations like insertion, deletion at both ends of the queue. Okay, and what are the most common operations that you would be doing in all of the containers? So one is you are adding some data, so that is known as insertion, okay, or adding. Then you might be doing searching, looking for data. Where is this data I have stored? Is it present or not? And third is removing, that is also known as deletion. So all of these containers will provide these operations in different time complexities that you should be knowing. Okay, then there is something which is known as forward list. So forward list is nothing but a single linked list. Okay, again, the data is stored linearly, but the memory is not continuous. Okay, and then there is something which is known as list. So list is nothing but it is a doubly linked list. You can expand both at the front and both at the back. In forward list and list, the memory allocation is not continuous, but in array and vector it is continuous. And Deque has a slightly different implementation. It's a complex implementation, so it combines various linear chunks of memory and it connects them. Okay, so it has a little complex implementation. Then there is associative containers. This is the second type of containers. Okay, so in the associative containers, what you have is you have something which is known as a set. So what is a set? Let us talk about set. So set basically stores the collection of elements. Let's say you have 1, 2, 3, 4, 5, and let's say you have multiple 4s. So set is going to store only the unique elements. That means it is not going to store the duplicates. Okay, but if you store them using something known as multiset, it is going to store the duplicates as well. Okay, so the multiset can have duplicate values. Secondly, set is going to store the values in an ordered fashion. Okay, the values would be ordered. That means they would be sorted. Okay, and how is this set made? So internally it might be using a tree-like structure, a balanced tree-like structure to implement a set. So next thing we want to talk about is a map. So what is a map? So map is a container that is used to store a collection of key value pairs. Okay, for example, you are in a restaurant and you have to order certain items. Let's say you want to order a pizza that costs rupees 500. Okay, and maybe you want to order a drink that costs rupees 100, or maybe you want to order something like noodles that costs rupees 200. Okay, so what we can say is we have something which is known as key, something which is known as a value. So basically we are inserting these pairs inside a container, and what this map will do, this will keep data sorted by keys. Okay, the data will be sorted by keys, and again it uses a balanced BST like data structure to store this data. So internally it might be stored like this. You might have a drink, okay, and then you might have noodles, or you might have pizza, something like that. Okay, so it is going to use a tree-like structure to store the items. Okay, so and they are going to be sorted. For example, A, B and C. You can see this is a height balanced BST. Okay, because the items are sorted by their keys. Okay, and if you do in order traversal of this tree, you will get a list of all items sorted by their keys. Okay, and you can even perform searching by going through this data structure. Okay, so multi-set we have already discussed. It is kind of a set which can contain duplicate keys, and multi-map is like a map which can contain duplicate keys. Okay, so one key can have multiple values. Okay, mango can be mapped with 10 and mango can also be mapped with 15, but this is not possible with map. This is possible with multi-map. So the thing to remember about associative containers is they use tree-like structures to store the information, and the data is ordered, the data is sorted. And if you don't want to store sorted data, you want to store data in any random fashion. Okay, so we can use the unordered associative containers. Okay, so we have unordered set. So maybe we want to store a set of numbers 1, 3, 4, 8 and maybe 2. So they must be stored in a random order inside this data structure, and now you want to look up whether this number 2 is present or not. Okay, so then this unordered set is very fast. It will give you the results in almost order one time. Okay, Similarly, we have something which is known as unordered map. It is like a hash table. Okay, it's like a hash table. And in hash table, again, you can do insertion, you can do lookup, okay, that is basically search, and you can do deletion. So all of these operations are done in order 1 time on average. Okay, the average time complexity is order 1. That means it is very fast, but it is going to tell you what is mapped with a given key. Okay, so anytime when you see, okay, map or unordered map, the data is stored in the form of key value pairs. For example, again, pizza has a value 500. If you look for what is the price of pizza in a list of items that you have inserted inside this table, it is going to tell you in almost order 1 time that pizza costs 01. Okay, pizza costs 500 in almost 01 time. Okay, or maybe you want to insert noodles in the hash map, so it is going to take almost order 1 time. Okay, then there is unordered multiset, which again it is like an unordered set, but it can contain multiple keys of the same type. Okay, so there can be repeating numbers in this set as well. Okay, so it is going to store all of them. And there is unordered multimap. That means you can have duplicate keys and those would be stored in the multimap as well. Okay, so these are unordered associative containers. Now there is one fourth category which is known as container adapters. So they provide a different kind of a interface to the for the containers. Okay, so one of them is stack. Okay, so stack can be easily implemented using an array or a vector or a linked list. But what stack provides is it provides different methods to access the data. Okay, it also restricts the functionality. You cannot have a look at all the elements. Okay, you can only look at the topmost element if you're using a stack. You cannot remove from the middle. You can only remove from the top, or you can see what is at the top, because stack hides the rest of the elements under the interface. Okay, then there is queue. So a queue again can be implemented using an array or a vector. So but queue supports the following operations. So why we are using these data structures? Because it is easy to think in terms of a queue or a stack when we are solving a problem in which this kind of a data structure can be used. We don't need to worry about what happens to the middle element, because we are only doing insertion at the back and we are going to remove elements from the front. Okay, so queue allows us to remove elements from the front and push elements from the back. Okay, so pushing is known as NQ. Removing elements from the front is known as DQ. We are removing something. Okay, push or insert or NQ, whatever you want to call it as. Then there is something which we call it as priority queue. So again, although it seems it's like a queue, but internally we know it's a heap data structure. Okay, so heap allows us to get the maximum element or the minimum element out of a collection of elements, and we can remove the minimum or maximum element. Okay, and we can insert any element. So heap allows us these three operations: insert new data, get max, and remove maximum or the minimum elements. Okay, so again these operations are supported in almost log n time, and this is what a priority queue is. Okay, so I hope you got a quick overview of the different type of containers that we have in STL, and that's all for this video. Hi everyone, in this section we will be looking at demo of various STL containers starting from array. So let us begin from array. So in order to use an array, there are two ways. One is a classical approach that a lot of people use to create an arrays. Okay, a classical way of creating arrays, and one is a STL based way of creating an array. So array is also a class that was introduced in C++ 11. Okay, and it offers some advantages over the classical arrays. So let's have a quick recap of how to use classical array and how to use the STL based array. So if I want to create a simple array in C++, so I will write some basic code. So let's see this code. So first of all, what I would be doing, I would be creating an array of integers. Let's say I create an array of fixed size. So I hope you remember what is an array. So array is a very simple data structure that stores all the elements in a fixed size sequence. Okay, it is a container in which the all elements are stored linearly, and it is of fixed size. Let's say the size is 6, so it stores, let's say, 10, 20, 30, 40, 50, 60. Okay, and the starting index is 0, the last index is n-1, so the indexing will be from 0 to 5. So this is an array of 100 elements. You can create an array like this, or you might say, no, I don't want an array of 100 elements, I want array of 5 elements. That you can do, and you can also initialize what are the elements in the array. So this is this you can do, or you can take input the elements of the array. That is also fine. So you can say, okay, for int I equal to 0, I less than n, where n would be what? It is size of the array divided by size of each integer. So this array is going to occupy how many bytes? Let's say each integer occupies 20 bytes, sorry, 4 bytes. So the size of the array would be 5 into 4 divided by 4, that would be the value of n, that is equal to 5. So we can say, okay, the number of elements is 5 in this particular array, and giving the size is optional if you're giving the elements, if you're giving the initialization list. Okay, so this is known as initialization list. If you give the initialization list, you don't actually need to define the size, that is completely optional. If I want to print the elements of the array, I can do it very easily. I can just see out array of I. Okay, and let's try to see this code. So we have array classical dot slash array classical. So we get 1, 5, 4, 3, 2, which are the elements of this array. We can put some space as well, and we can do the same work as well. 1, 5, 4, 3, 2. So now one thing we have to notice, how do we pass arrays to functions? Okay, let's talk about passing arrays to functions. Let's say I have a function like update array. Okay, suppose I want to update a particular element of the array. Let's say I will update the 0th element or a particular ith index. So what I will get the array, and I will also get the index of the array. So I would say array of I, this is equal to, or the new value that I want to put. So I can say array of I, this is equal to value. This is going to update the array. For example, I want to say update array and take the index, take this array and take the index 1 and make this number as 13. Okay, and if you now print this array, you will see the first index is becoming 13. That means when you are passing this array, no actual copy is no copy is created. Okay, so the array, you can say it is passed by reference. Now we need to understand why it is passed by reference. Okay, so what happens is this array name, okay, this array name, it actually stores the base address of the array. Okay, let's say this array is 1, 5, 4, 3, 2. So when you're passing this array, let's say this address is 2022. So now what will happen is when you're calling this update array function, so this is also like a pointer. Okay, it is, you can also write it as int star array. Okay, so they are same. Writing this or writing this is same in the function call. So effectively you're creating a copy of this variable. Okay, you're creating a copy of this variable, and this address is 2022, which is stored here. So this address is also 2022. So effectively this is also pointing to this location. Okay, so when you try to update array of I, so how does this break down by the compiler? So the compiler says this is array plus I. Okay, so that means it will take a jump of 1 if I is 1, so it will come to this address, which is 2026. Okay, so effectively if you say I will take a jump of 1, it will go to the next box. If you take jump of 2, it will go to the two boxes ahead. So in the memory it is going to this address 2026, and it tries to dereference this, and it puts the value that is equal to, let's say, 13. So what is going to happen? You're going to come to this location and you're going to make this value as 13. So that is why you can see the actual array is updated. Okay, in this case, the actual array is updated. Okay, so now why I'm teaching you this stuff, because when you're going to work with STL array, all of this is not going to happen. Everything is going to be a copy of the original object, and you have to pass the objects explicitly by reference. Okay, we will see it very shortly in the next video, but in this case the actual array is updated. Okay, actual array is updated. So this is one thing that you should be knowing, that arrays are passed by reference because they're passed by making a copy of the address, and this array variable also points to the original array. Okay, and you can also have a function to print the array. So in order to print the array, you always need two things. One is the base address of the array, and second is the value of n. Okay, so what you can do, you can say for int I equal to 0, I less than n, I plus plus, I will iterate over each and every box and I will print the value of array of I. Okay, so now instead of writing this for loop here, what I can say, call the print method. So in order to give the print method, I will give the array and the value of n. So let's build the code and let's try to run it. And you can see we are getting the same output. So one thing to notice, when you have to work on all the elements of the array, you also need to pass the size of the array as a parameter, because this array does not know how big is the array. This is just the base address of the array. Okay, this is just the base address of the array. It does not know how big is this array. Okay, so if you simply do cout print the base address. Okay, so the base address is nothing but cout arr, and I can say endl. So let me show you the base address. So you can see this is the base address. Okay, so addresses are printed in a hexadecimal format. Okay, so whatever is this number, it is converted into hexadecimal number before printing, while printing, and hexadecimal numbers start from 0x. Okay, so all addresses will follow this form if you're coding in C++. So all addresses are hexadecimal addresses. This is nothing but the base address of the array. Okay, another thing I want to tell you is why you can't do size of the array. If you do size of the array in main, and if you do size of the array inside a function, there is a difference. So let's see that difference as well. Void, let's say array size. So suppose if I pass the array to this function and I say, okay, cout array size in function, and here let's say you do size of arr. Okay, and if you do size of arr here, so cout array size in main, and let's say size of arr. Okay, and cout endl and cout endl. So now this is an important thing you should be understanding. So we are getting a warning here, size of array function parameter. So there is one warning. So the warning says array function parameter will return the size of int star instead of int array. So this is actually same as writing as I discussed. Either you write this or you write int star arr. Both are same. Okay, both are same. But in main, this is an actual object. But in a function, this is only an address. So let me tell you, let me show you the code output. So array size in main is 20, and we have not called this method array size. So let's call this method array size, and we pass it the array as well. And now let's run the code. So you can see array size in main is 20 and array size in function is 8. Now how this is happening? Okay, so inside main, when you do size of array, you actually get the size of this array. Okay, that contains 5 elements. So 5 into 4 is what? It is 20 bytes. But inside the function call, when you're saying, okay, I'm going to pass this array, you're actually copying the address, let's say 2022, that is the base address, inside a pointer variable. Okay, this is nothing but a pointer variable. This is not the actual array object. It only stores the value 2022, which means it is pointing to this one only. So inside main, you're getting the size of the array as 20 bytes. Inside the function, you're getting the size of this array, which is 8 bytes. Okay, because pointer variable is taking 8 bytes to store this particular address. Okay, and that is why you cannot execute this statement inside a particular function like array size or inside print. Okay, so that is why I have explicitly passed the value of n. Okay, this value you won't be able to generate inside the function, so you have to pass it explicitly. So this is how we work with classical arrays. So we try to cover through some common pitfalls that people might be doing. So if you have this knowledge, you can easily work with arrays. And in the next video, I will show you how to work with the array object that you can create using a STL based class. And that's all for this video. Hi everyone. So let us talk about arrays that are present in C++ STL. So for that, you need to include the header file called #include_array. And the way to create this object is you have the array class, which is part of this header file, and you have to define what kind of objects this array will hold, maybe array of a dog or maybe array of an integer. And second thing is you have to give the size of the array. Okay, so let's say the size is 6 and you create this array. Okay, now what you can do, either you can take input and store it in this array, or you can simply give an initialization list. Just for a simple example, I've created an array of 6 elements and I have initialized what all elements are in this particular array. Now let us see how we can work with this array. Suppose I want to update a particular element, so I can say, okay, array of 0, this is equal to 10. So it will work in a similar manner. And suppose I want to print the number of elements, so I can say for int I equal to 0, I less than n. So now n, how do we get the value of n? So this is an object. Okay, so this is an object of the array class, and array class has a method called size. So array.size will give us how many elements are there in this particular array. So I can say, okay, see out the value of array of I. Okay, let's try to build this code and let's also try to run this one. So I can say /array .cpp, /array, and I get all the values of this array. You can see array of 0 is updated as 10 and we are getting 10, 2, 3, 6, 7, 8, 10, 2, 3, 6, 7, 8. Yes. Now one thing is how this object is passed to a function. For example, I want to create a function to update an array, let's say. So I can say void update array and I will pass in this object. So this object is of this type, and I can say array of let me take an index and let me take the updated value. So I can say array of I, this should be equal to value. So what I'm going to do, instead of doing this operation here, I'm calling the method update array and I'm saying take this array, take the index and take the value. Oh sorry, the I should be 0 and let's say the value is now 100. So if I run this code, what I can see is the array is not updated. The array is not updated. Now why it is happening is, in this case, this array is an object. Okay, this array is also an object, and this object is nothing, it is a STL container. And one thing we should remember is all STL containers, okay, all STL containers, they are passed by value, So what is happening in this case is you have created an array in main and you are saying, okay, I'm passing an array to the update function, which is a copy of this array. So you're actually creating a copy of the original array. So it is like, say 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So this is the array in main, and this is the array object inside update. Now if you make a change inside this update array, this value becomes 100, and the actual array in the main, it is not changed. The actual array is not changed. So what you need to do, if you want to make the changes in the actual array, you have to use pass by reference. Okay, you have to pass by reference. So how the containers are passed by reference, let us see. So in order to pass any STL container by reference, you have to create a reference variable here. Okay, so now what happens is we have one array which is like this, and we have an array object in main, and this array is a reference variable for this object. Okay, so you're saying array int and ARR, this is equal to ARR. Okay, and you can give it any name. You can give it a name like some X array. Okay, and even this X array would be same. So if you now run this code, you can see the actual array is changed. Okay, so the actual array is changed. So both X array and this array, they're pointing to the same object in memory. Okay, so they refer to the same object in memory. So there is an object in the memory which now has two names. One name is ARR. Then when this function is called, it gets a new name, that is XARR. Okay, so this object can be accessed using two names. Okay, we call this as a alias. That means you have a name, you also have a nickname. So now this X array and this ARR, they are the same object. And once this function call is over, this name is gone because the scope is only present inside this function. This name will not exist, and hence once you're coming back in the main, you're printing the array, and that is how it is working. Now there is one more thing. Let's say you want to create a print method. So in the classical array, we saw that we have to pass the value of n as well. But in this case, since we are passing the entire object, we are not passing the base address, we are passing the entire object. So in that case, if you want to write a print function for this kind of array, what you can do is you can say, okay, I will pass this array to this function, and I will say, okay, for int I equal to 0, I less than n. And what is now n? So n is nothing but array.size. So this thing, and you can say cout array of I, and now you can call this function print array. So you can say print ARR, and that makes the work easy for you. And let me show you the code. So again, you get the same output, and maybe we should print some space as well. So this is printed by the print function. Now how you're passing this array? Again, you're passing it by value. That means you're creating a copy of the array. So if you don't want to create a copy, you can say, okay, I will pass it by reference. And if you want to make sure that your object is not changed, you can make it as a const also. Now what this const is going to do, it is going to make sure that this is a print function. This should be a read-only function. Okay, that means it should not be modifying the values of the array. So if you say array of 0 and you make it as, let's say, 100, then you are going to get an error, because this is a constant parameter. Okay, this is a constant parameter. It should be used in a read-only mode. It should not be modified. So if you want to adopt good coding practices, then using const with read-only data members is what you should be doing. So this is how ideally it should be passed. But yeah, so this is the correct way of writing the code. Okay, so we want to use this in a read-only mode, so that's why we are using this as a constant parameter. It does not change inside the function. Okay, but you can change it here. You can change it in main. Okay, so you can say array of 0, this is equal to 100, and this will now work fine. Only for that function the array is read only. Okay, but in main you can change it. But if you put a const here, then again a similar thing will happen. You will get the same error. Okay, so that is where we generally use const, and This is how the array objects are passed. Now we can also talk about some more methods to work with this array. So maybe I can say I want to sort the array. Okay. So in STL containers, we also have one more concept, that is the concept of a iterator. Okay. So what we can do is we can say, okay, I want to sort this array starting from this point till the last. I say, okay, give me this address. So this would be given by array.begin, and the address which is after the last element, okay, the location which is just after the last element, it will be given by array.end. If you want to sort the entire array, okay, so let's say now array of 0 is 100, let's say this is 16, this is 8, and this is, let's say, 70. So if you want to sort the array, you will say sort array.begin till array.end. So now we will have to import another file that is known as algorithm. This file contains some common functions like sorting, searching. Okay, so it is an inbuilt sort function, and now if we print this array should appear in a sorted manner. So you can see we are able to get a sorted array. So the same thing if you have to do it with a classical array. So this is our classical array. So again you have to import #include algorithm, and what you have to do is you have to define the starting and the ending point of the array. So you have to say, okay, in order to sort it, you have to say sort array.begin. So begin will not work with the classical array. So you have to give the starting address, that is array plus 0, or you can write it as array, and you have to give the address of the last location which is after the last element, so that is array plus n. So the last element is at n-1, so the next location would be array plus n. So this is how you can do the sorting with the classical array as well. Okay, so maybe if I said /array classical, you can see this is the sorted array. Okay, so we made 5 as 13, and then we did sorting, so we get 1 2 3 4 and 13. So this is with the classical array. So I hope you have understood some basic methods, and these are some of the commonly used things that I have told it to you. And there is one more thing, there is one more common operation. So in some cases you might be required to initialize an array with all zeros, or you might be doing array with all ones. So in that case we can use a method called fill. So let me create an array of zeros, let me call as array of 5s. So I can say array of integers with 10 elements, and let me call it as 5s. So I can say 5s dot fill, every value is 5. Okay, I want to fill every value in this array as 5. So I can say, okay, for int I equal to 0, I less than 5s dot size, I want to print each element. So I can just see out 5s of I. So let me show you. So this array will contain all 5s, /array. So you have all 5s in the array, you have 10 number of 5s in the array. And let's do cout endl. Let me just comment this thing out. There is one more method that we can use, the for each loop. Okay, so we can use this loop also to easily iterate over any array. So maybe I can say for some auto or some number integer x that is there inside your original array or in the 5s array. Okay, you can just see out x. So let me show you how this loop will work. So this is done using the normal for loop, and this we have printed using a for each loop. Okay, this we have done using a for each loop. So let's see how this loop works. Let's, instead of iterating over the 5s array, let's iterate over the original array. And so now what we are getting the elements of the original array. So let's see how this works. So you have elements like 2 3 8 16 70 and 100. So I say, okay, x is going to assume each and every value in this array in each iteration. So we have x, which is initially 2, we print it. Then we get x, which is 3, x gets the value 3, we print it. Then x gets the value 8, 16, and so on. So what we have said, we said for int x, which is there inside the original array. Okay, so here we are not iterating over the indices, but we are iterating over the values inside the array. This kind of a loop is known as a for each loop. We have similar loop in Java, we have a similar loop in Python as well. So this is colon. Okay, this is what? This is a colon operator. So it simplifies the syntax of iterating over the array. So you can use this for each loop with the array container as well. So I hope you're now clear with the how to use array containers, and we have discussed the commonly used functions with arrays containers. Okay, so that's all for this video. Thank you. Hi everyone. So we have talking about sequence containers, and we have already seen how do you work with array based container. Okay, and the next container that we will talk about is a vector. So what is a vector? Vector is a dynamic array. Okay, so what is the meaning of a dynamic array? So it is an array that can grow in size. So we'll look at how this works. So we have already discussed about the array class, and we have also discussed how they are different from the classical C styled arrays. And there are a lot of methods associated with each and every container that you do not need to remember. Okay, so I'm saying do not need to remember, because you can always look up at the documentation and if you want to look for a specific method, but there are some common operations that you must be knowing, that how do you access the ith element, or how do you get the size of the array. And there are two more methods which we have not discussed. There is a method called front that gives you the element at the front of the array, and there is a method back which gives you the last element. Okay, so ideally you can do it using array of 0 or array of n-1 as well. So this is the element at the back. So there are lot of other methods as well which you do not need to remember. You can always look at the documentation, but one thing you should be remembering is, in an array, in order to access any ith element like this, or you can use the art function, all of these operations are order 1 operations. Okay, that means you have the random access to any element in constant time. And now what we are going to do, we are going to talk about vectors which are very similar to arrays, but they have a special power as well. Okay, so that special power is they have the ability to resize themselves when an element is inserted in the array. Okay, for example, you have a vector which is currently of size, let's say 4, and you want to insert one more element in this vector. Okay, let's say the vector is of size 5. You want to insert one more element. Let's say the element is 20. So you inserted it. Now you say, okay, I want to insert one more element in this particular vector, but the vector is full. The vector is full. So what it is going to do? It is going to resize itself when an element is inserted. Okay, now how that resize happens, I will give you a quick recap. So the vector doubles itself. Okay, so if the original size is 5, it is going to create a new array and this array is allocated dynamically on runtime. Okay, and it is going to copy all the elements of the previous array. So it is going to copy 1, 2, 3, 4, 20, and now you can see this had a capacity of 5, and this vector has a capacity of 10. That means it has doubled its capacity, and you want to insert a new element. Let's say you want to insert 21, so that 21 would be present here. Okay, so this vector has a concept of reallocation happens when the underlying array is full, and second thing is these locations are continuous. Okay, that means if this address is 100, the next would be 104, the next would be 108, next would be 1112. So these are continuous addresses. Now why this is a difference of 4? Because each integer box takes 4 bytes. Okay, so the original array would be deleted. The original array would be deleted, and you would have a new array at a new memory location. Okay, so it uses dynamic memory allocation to create these underlying arrays. Okay, so dynamic memory allocation. So again, it is a sequence container. So all the code that is responsible for reallocating the memory, it is already written by the people who made STL. You just only need to call some of the functions to work with the vector. Okay, so you have the square brackets as a overloaded operator. You have square brackets as a overloaded operator, and you have this clear method as well. If you want to remove everything from the vector, you have a method called pop back. If you want to remove the last element, you have a method called push back if you want to push something from the back. Now it is very important to think, why don't we have a method like push front or push back or push front in the vector? Okay, because you're working with the array, so all the empty locations are on the back of vector. If you want to push now 50, so you will call, okay, push back 50, and that will insert 50 inside the vector. Okay, that is going to insert 50. And if you want to say pop back, it is going to remove 50 from the vector. Okay, and this can be done in order one time. So there are again a lot of methods. So I'm just highlighted the important ones. Like reserve, you should be knowing. The reserve is used when you're sure that, okay, I need at least this much space to work with the vector. So in that case, your memory would be reserved for that many number of units, So that's how you are going to use the reserve method. Okay, for example, you're sure I will need at least 1000 elements. That will make sure in the beginning your array is of size 1000, and then if it exceeds 1000, then it will double itself. It will make itself as 2000. Okay, so we have pushback that inserts at the back. We have pop back that removes something from the back. We don't have push front because there is no additional space to push something on the front of this vector. You cannot have anything at index -1. Okay, you cannot push directly at the front without doing any shifting. So that's why we don't have push front or pop front methods. Okay, so no push front, no pop front inside the vector. And there is a method called clear that is going to remove all the elements. It is going to make the size of the vector as 0. The capacity may not change. Okay, the capacity may not change. So let us look at a demo. Let's look at a demo of how do we work with vector. If you want to create an empty container, you just say, okay, vector followed by the data type in angular brackets followed by the name of the vector. Okay, and if you want to create a vector using a fill constructor, okay, that means you want to create a vector in which every number is 20. So for that we can use something known as a fill constructor. So we say, okay, 4 boxes, each of value 20. So this is your vector, and once it is full, you want to insert something more, it will double itself. It will make itself as 8. And there is also a range constructor. You can also construct a vector from an array. So this is nothing but an array, and you're saying, okay, I'm defining the range starting from this point till this point, put all these values inside a vector. So this is how you use the range constructor. There's also something which is called a copy constructor that will take another vector as an object and it will create a copy. Okay, it will create a copy. So that means if you have a vector of 10, 20, 30, 40, this is third, then you will create another vector that is copy of this one. Okay, so for that we can use the copy constructor to create an object, and most of these ways are common for many STL containers. Okay, and you do not need to remember each and every way. You can also construct a vector using an initialization list. Okay, you can say, okay, these are the numbers I want to use to create this particular vector. Okay, so let's talk about one more way. So you can also say, okay, I will take inputs and I will push back those inputs in my vector. But if you know that you already have a vector which is of size 100, then you can also say, okay, v of 0, this is 1, v of I, this is equal to 20. You can access the ith index provided I is less than the capacity of the vector. Okay, So the capacity means how much storage has been allocated for that particular vector. You cannot say I is this location, make it 100. So you will get a memory error if your I goes out of bounds of the capacity of the vector. Okay. So some of the common functions, like you want to access the ith element, you can either use at or you can use square brackets. You can get the current size by using the size function. You can get the underlying capacity, that means how much memory has been allocated, using array.capacity. And you can also get the maximum size, that means how much memory is available due to available RAM, and for that you can use array.max_size. Okay, so this is an example of using the pushback method. If you want to push something in this vector, you will say, okay, array.pushback 20. So this will add 20 to the vector, and if the capacity is full, then it will double itself. Okay, and if you want to remove something from the back, then you can call the popback method, and this is also an order 1 method. Okay, so array.clear, like you want to remove all the elements from the vector, so it reduces the size to 0. Okay, so size is not same as capacity. Size is not same as capacity. That means currently we have an empty vector, and if the original capacity is C, the capacity is going to remain same, but the elements are not going to be there in the vector. So when you start pushing back in the elements again, they are going to push from the 0th index, maybe 13, 14, 15. They will get stored after clearing the original vector. Okay, and there are some more methods like erase or insert. So now we will look at a quick demo of how to work with vector. So let us look at a demo of working with the vector. So first we need to include the header file. Okay, and that's, let's say, vector. And what I'm going to do, I'm going to simply create a vector. Now there are multiple ways. There is a fill constructor that we can use, or there is a range iteration that we can do on an array, and then we can make a vector. So let's create a very simple vector, and I will take input a value of n, and I will take input that, and I will push n elements in the vector. Okay, so for int I equal to 0, I less than n, I plus plus, I can say, okay, let's read those inputs. So int some number, we will see in that number, and we will say, okay, v dot push back that particular number. So now if I show you the code, we also have to, let's also print the size of the vector after each insertion. Okay, so maybe let's print the capacity, and that is v dot capacity. Okay, and let's also print the size after each insertion, so that is v dot size. So now let's see, let's say I want to insert 10 integers in my vector. So I can say, okay, that is 10 and followed by 1. So in the beginning I inserted one number, so it created a vector of size 1, and that stores 1. Then maybe I store 10, so the capacity is 2, the vector doubled itself, and it is storing the number 10. Okay, maybe then I store 20, the capacity becomes 4, and it is storing the number 20 here. Then I again insert 30, the capacity remains 4, and we have 30 here. Okay, and now if I again insert something, let's say 40, the capacity will double itself. It will become 8. The capacity will become 8, and the size would be 5 because we are storing 5 numbers. Okay, then let's say 50, same, 60, same, 70, same, 80, and now it is full. Okay, now it is full because 50, 60, 70, and now it is full. Now the size would become how much? 8 into 2, 16. The actual size would be now 16, and this would be storing 10 numbers, let's say 90, and you can see what happens now. Okay, so the size is 10, the capacity is 16, and the vector is storing actually 10 numbers. Okay, we are storing 10 numbers inside a vector. So what you are observing is there is a repeated doubling operation that is happening, and this is an expensive operation. Every time the doubling of the memory happens, okay, you are spending linear time to double the array. Okay, you're spending linear time to double that particular array, and that makes your pushback operation in some cases as a linear operation instead of a constant operation. Okay, so on an average it is constant, but when the doubling happens, it becomes a expensive operation. Okay, so in order to avoid that, what you can do, you can say, okay, v dot reserve. I know there would be at least 100 elements in the vector, then why I should start from 10? So now you can see if I push 1, sorry, let me build the code and let me stop this, clear this, and if I say, okay, let me push 1, so the capacity is 100 from the beginning. Let me push 2, the capacity is 100. So there is no doubling that is happening until you have reached 100 elements. Okay, until you have reached 100 elements. Or so this is one way you could have done. Another way could have been, you say, okay, I want to create a vector of 1000 elements, each initialized with the value 0. So this is also going to make the capacity of the vector as 1000 in the beginning. Let's say 10 elements, I insert 100. So the okay, so in this case, what happens is, when you're using this fill constructor, you have already said, okay, we have already filled 1000 elements in the vector. Okay, and now you start pushing from 1001th position. That is going to double this vector. Okay, so you have to observe that there is a difference. There is a difference between using a fill constructor and calling v.reserve. Okay, so you have to make sure that you do not confuse these two. So right now I would be just saying vector of int, and let me call it as v. Okay, then I say, okay, reserve these many elements inside a vector. Similar to pushback, we have popback, we have we can also print the vector. So we can say, okay, for every element, go to the vector, and you say, okay, for every element that is there inside your vector, you go and print it. So you say cout x. Okay, so let me take input n elements, I will push them into the vector, and I will print those elements. So let me say I want to give 5 elements, and let's say elements are 1, 2, 3, 15 and 4. So now you can see it is reading all those elements. The capacity does not change because we have used the method reserve, and the size is increasing as we are inserting those elements. So this is the output, and this is how you get all those elements. You can also do sorting on the vectors, like sort, you can say v.begin till v.end. Okay, and that will give you the sorted output. Right now I'm just going to comment this thing out. I don't want to see capacity again and again. So I can say, okay, 5 elements, 5, 4, 1, 3, 2. So you get 1, 2, 3, 4 and 5. So this is how you work with a vector, and that's all for this video. Hi everyone, in this lecture we will talk about doubly ended queue, which is also known as Deque. So Deque is a very simple container. It is a sequence container, and with dynamic size that can expand and contract on both ends. So this is a very special property that you should remember about Deque. So as the name suggests, it's a doubly ended queue. So it can expand and it can contract on both sides. Okay, so basically you have a container like this, and what you can do, you can push data from the front, which is known as push front. You can pop data from the front, which is known as pop front. You can push data from the back, push back. You can pop data from the back, pop back. Okay, so when you have something like a problem in which maybe you want to implement some sliding window kind of an algorithm, in which you're maybe adding data from here and you're maybe removing data from here, or maybe you're also adding data from here and you might be removing from here as well. Okay, so maybe a window which can expand and contract on both sides. So in that case, you might be using this kind of a data structure, which we call it as Deque. So Now let's also learn about few more points about Deque. So one thing is the internally the implementation of the container is quite complex, and it is not guaranteed that you will be storing everything in a continuous memory location. Okay, so the two addresses may be different as well. Okay, and elements of the Deque can be scattered across different chunks in the memory also. Okay, so it is not guaranteed internally it would be linear, but for you it would behave like all the elements are stored sequentially. Okay, so let us talk about few important methods of Deque. So you can access any element. You can say give me the ith element of the Deque using the square brackets, which is an overloaded operator, or you can use the add function. Both are same. And if you want to see what is the last element, you can call the back method. If you want to remove all the elements, you can call the clear method. If you want to get the front element, you can call the front method again. So these are 4 important operations that you should be knowing: push back, pop back, push front, pop front. Okay, and there is size method that tells you how many elements are currently there in the Deque. So let us look at a few ways to initialize this Deque. So you can create a Deque like this, or you can use a fill constructor. Like you can say, okay, I have empty Deque. Oh, I have 4 integers with a value of 100. So this is going to create a Deque in which we have 4 numbers and everything is initialized as 100. Okay, or we can use we can iterate over another Deque and we can create a third Deque as well, or we can also use the copy constructor like we did in vector as well. Okay, so these are few ways in which you can create Deque. You can also use an array and you can iterate over the elements of the array and you can give those elements in the Deque. Okay, otherwise you can use the operations like push back to insert some integer into the Deque. Okay, or if you want to remove, pop back, push something at the front, push front, remove something from the front, pop front. Okay, so you do not need to remember each and every method. You can always look up at the documentation, but these are few things that make Deque special, that insertion and deletion at both ends you can do very easily, and that too in constant time. Okay, so let us also look at a quick demo in the code. So let me create a Deque of size 10. So I can say Deque of integers, and it stores 10 elements. And now what I can do, I can say, okay, for int I equal to 0, I less than 10, I plus plus. Now the memory is already created. What I can do, I can say, okay, Deque of I, this should be storing the number I into I, that is I square. I'm storing I square in the Deque, and let us try to print it. For auto x that is there in Deque, I can just see out x. So let's see what output does it produce. So we have built the code and now we can run the code as well. So I can say, okay, let's run Deque. So we are getting the numbers from 0 to 81. That means we are getting the squares of these numbers. Now what we can do is we can also say, instead of using a loop like this, maybe you might be doing for int I equal to 0, I less than 10, I plus plus. So you can also do cout Deque of I, and this is also allowed, or you can say cout Deque of at of I. Okay, dq dot at of I. So at method is supported in all the containers, most of the containers which have like the sequential interface. So we can say, okay, so this also works, this is also fine. Okay, you can access any ith element either using add or using square brackets. So let me show you an example of let's first print the capacity of Deque. So I can just cout dq dot capacity. Okay, and let's also print the size of Deque. Sorry, Deque does not have the function capacity. Okay, it is only with the vector, so we'll not print capacity, we'll only print the size. So let's build the code and let's try to run it. And okay, so the capacity is 10, And if I do pushback, if I say, okay, oh, the size is 10, if I push something into deck, let's say deck dot pushback 123, that number would be there at the back. So now you can see the number 123 is there inserted at the back of the deck. Okay, and if you do push front, then this would be at the beginning of the deck. So let me show it to you. And you can see it is at the beginning of the deck. So there are methods that allow you to insert something in the middle of the deck, something remove from the middle of the deck. Those are also done there, but they take linear time. So ideally, for most of the use case, we would be dealing with these methods, insertion and deletion from both the ends. Okay, so I hope you got a quick idea about deck, and that's all for this video, and thanks a lot. Hi everyone. So now I'm going to tell you about the C++ standard template library for the stack that is available for use for everyone, and you can use STL while solving online coding challenges. Okay, you can also use it during your interview rounds. And what this library offers is, it offers you implementation of most common data structures that we are learning in this course. So learning data structures is important because you understand the core concepts of data structures when we are going through the implementation. Once you understand the core concepts, for every problem, you don't need to repeat the same data structure. You don't need to write the code for the data structure again and again. Okay, so we want to reuse our code, and for most of the data structures, the code is available, and hence the library for the stack is #include stack. So this is not written by me, it's written by the people who built the C++ standard template library framework, and that provides the direct implementation of stack. Let's see how we can use this stack. So firstly, you define the class that is stack, then maybe you type the data type, maybe a stack of strings, and maybe let me call it as books. So I can say books.push, I can say C++, and then I can say some more books I can push, maybe a Java or maybe a Python or maybe an operating system book. Now here you can see it is very similar to what we have done, and we actually tried to replicate the same functionality that is provided by the STL stack. So what I can do is I can say while this stack is not empty, so it supports an empty method, it supports what is there at the top, it supports the pop method, and it also supports the push method. Okay, so let's build the code. Okay, it says undefined identifier. S is no, sorry, this should be books. The name of the stack is actually books, so I was using S. Now you can see the code is getting built fine, and it is using the inbuilt stack that is provided to us. So yes, it has an empty method, top method, pop method, push method. You can also read about more details in the c++reference.com, c++.com, sorry. And let us run this code and see. So /stack STL, and we are getting OS, Python, Java, and C++. That means the stack is working as expected. Yes, working perfectly fine. So that's all for this lecture. Thank you. Hi everyone. In this lecture, I'm going to tell you about the Queue STL, the Queue standard template library. So that is present. The queue class is present in the file #include queue. So you have to include this, and once you include this, you can easily make a queue of any data type. Let's say queue of integers, and maybe let us try to insert some numbers in the queue. So queue.push, let's say 1, and maybe 2, then 3, then 4, then 5, and then 6. So what we will do, we will try to print the entire elements of the queue, and we will remove everything from the front. So while the queue is not empty, so we will do cout queue.front. So the STL also provides this method, and we can do queue.pop. Okay, that's it. And this is how we can use the inbuilt C++ standard template library Queue. And now we can actually try to run our code as well. So let me show you. So we are getting the output in the same order. That means it is a FIFO kind of a queue. All right. So that's all for this lecture. Thank you. Hi. So in this lecture, I will tell you how you can use the inbuilt priority queue class in C++ as a heap data structure. Okay. So firstly, you need to include the header file, that is queue. And after that, you need to make a class priority queue. So this class is already defined. So we will create an object and each node will contain an integer. So let's call it as a heap. And now this is a variable. Okay. This is the data structure that we are using. What we can do, we can iterate over all the elements in our array. And let us try to insert all those elements in this particular priority queue. So priority queue, as the name suggests, each element will come out of the queue with a certain priority. In this case, the priority is the element with the higher value has a higher priority. Okay, so let us see if I can say heap dot push x, and let us build the code, and it is working fine. Now all the elements are added inside the heap, and internally it would look maybe something like this. You will have 90 at the root node, then it would have maybe 20, or maybe it would have 10. Okay, so I don't know, but internally the structure would look something like this. So what we can do, we can keep on removing all the nodes one by one from this heap and see what is the output we get. So we can say while this heap is not empty, so while not empty, let us try to remove one element that is at the top of the heap. So I can say cout heap dot, I think the function is called as top. Okay, and then I can call the heap dot pop function. So top function displays what is at the top, and pop function removes that topmost element. Okay, so and now we can run this code. We can say dot slash the file name is sorting using a heap. If I now show you, you can see we are getting the elements in a descending order. That means we are able to do sorting using a heap. But now you may ask, what if I want to sort these elements in a reverse order? Okay, so by default it makes a max heap. Now you can say it is a max heap by default. So if you want to min heap, then what we can do, we have to provide two more parameters. One is called vector int, and there is another comparator. Okay, so it's a, you can say, inbuilt comparator that will reverse the comparison. Okay, this will convert this max heap into a min heap, and if I now run the code, and you can see we are getting these elements in a reverse order. So this is inbuilt comparator. Okay, it has reversed the comparison that heap was using internally to compare two elements. If greater element was going to the top, now the smaller element is going to the top. If you don't want to use this kind of a comparator, or maybe for a complex object, you can also write your own custom comparator. Okay, so let me also show you how we can write those own custom comparators for this particular class. I will maybe make a copy of this code, and I call it as, let's say, custom compare dot, and here we are going to define class compare, and inside this class we have to define a method. So we can say bool operator, and now if you look, we are doing operator overloading here. We are going to get two numbers, int a and int b, and we are going to compare them. So this compare function we will not call directly. The heap class will call it internally whenever it is comparing two elements. Okay, so we can say return let's say a greater than b. So this function is public because it would be called from outside the compare class. And then we have this operator, that means we are overloading the round brackets, and then whenever we are doing a comparison we get two numbers which are as arguments, and based upon the logic it will return true or false. So if a is greater than b, it will return true. So if I, instead of doing this, if I simply send the compare class, okay, So if I do sorting using heaps, I get this output. But let's say if I change this comparison here and build my code, and I get I should get a, okay, this is the output. And if I do it like this, I build the code, and okay, so it is my mistake. I'm running the wrong file. It's not sorting using heap. The file name is custom compare. So /custom compare, and you can see we are getting the elements in a sorted order. But if I change this now to like this one, we get the reverse order. Okay, so this is one thing you can do in some of the problems, and we will see more such application in coming lectures. Okay,